a millennial. We're here. Hola, we are back here. Oh my God, this is ridiculous. This is where I'm going to say one more time, if I get 1,000 people, I don't have to use this. Please don't laugh at me, everybody. I'm just leaving it. Laugh out loud. Okay, so we have a lot of people here. So I don't know all these people, but we have like a Mary, Aaliyah. Maybe they are even in the same class, because there were a couple teachers that wanted some help, and so I told them that I made these. So maybe they're from the same class. So this time we are going to do kinetics, and we're going to do, I know Eli's like, don't go by the screen. I'm doing it anyway, Eli. So I'm just going to say who's here. Eli's back to tell me what not to do. We love Eli. He actually has his brother here. I'll just leave him nameless. He's in college. He's going to tell me if I do things wrong or if I just quit. He's going to jump in. Alex has not been here, right? Abby's back. Josh is here. Emma is back. Were you at one of these? Andrew is a first timer. I was talking about him though. We think we were running track the other day. So he couldn't be here. Richmond's back. Woohoo, Richmond. Kylie's here. She'll probably start coughing. And Dane is here. Okay, so if I make mistakes. This Justin is here. Hello, Justin. Hello, Justin. Hang on. And then I just got to get going. We're going to play something called Picture Pages. And it was when I told my student teacher who just graduated, I sang picture pages, time to get your crayons and your pencils. He didn't know the song. And then I looked it up and I found out that it was actually a show in the 80s. And my student teacher, I think, was born in 1997. He had no clue. So you need to look that up later, what Picture Pages is. It was a little kid show that ran in the 70s and 80s and 90s. I don't have a marker that makes the fun sound, though. Don't do that tonight. Do that after the AP exam. Unless you need to laugh, then watch it, because it'll be funny. I'm serious. All of you in here should go home. Just look up Picture Pages. Bill Cosby. I'm not trying to promote him, but he's done some different things since Picture Pages. Let's not get into that. This will have to be rated like a different rating. But anyways, I'm going to show you the pictures. I'm going to try not to hold them in front, or like Dane laughed at me, push them right up against the camera. So I'm trying this. If you're an AP Chem student, you should recognize what I'm putting in front here. It's a ring stand. Okay, so what you need to do, bam, there's my really fancy setup. You need to write down what you know about this picture. What's different? What can you label if this showed up tomorrow? At what time? 8. But our students have to be, I'm going to move this over a little bit. Our students, by the way, if it's any of my students, you need to be at the place, I won't say where. I said 7, but that's a little early, but just tell yourself 7 and then you'll get there at 7:15. Don't be late. The person who is the brother here was almost not there. And the whole class was freaking out when he didn't show up, because he did do really well and they were worried that we wouldn't have had that number. We won't say what number it is, but you can figure it out. So I'm going to have them say hi, just so you know that I do have students here and I'm not like at school at 7 o'clock making videos because I have no life. Okay, here we go. So Richmond, say hi. Say it louder, Richmond.
Hi.
There. Okay, Kylie, don't start coughing.
Hi.
Hi. Dane?
Why?
Dane just says why. This is stupid. Emma?
Hi.
Hi. Josh?
Hi.
Here's Josh. Andrew's new.
What's up?
There's a new voice. Eli.
Hey.
And then his brother.
Hello.
There we go. Alex.
Hi.
And then Abby. Oh, that was really loud. I had that for music. We were playing this song.
Oh, that was stupid, by the way.
This is also 80s. This is Living on a Prayer.
You don't need to have music to erase a board.
Eli's just negative. Okay. If you had him in class all year, you would understand. Here we go. What do you know about this picture? Okay. Write it down. I'm going to start drawing it. You label it. All right. Then I'm going to hang up a different picture later. Let's do this one first. Okay. So I'm going to draw it behind me. You stare at that one. Here we go. Very big. Is this okay, Eli, if I draw these really big? Or is that not okay with you?
No, that's good.
Okay. And then what do I do with this? And then kind of like that. That's a little, something like that. Okay. Here we go. Okay, so I have them behind me, and what I need you to do is label what you know. So I had the coordinates. What were the coordinates? I'm going to make my students say out loud what the coordinates were. This was called. Did you guys write it down?
Reaction coordinate.
Yeah, reaction coordinate. Now, what that means? That just means time. It means the reaction's happening. So start, end. That's simple. Okay. What about over here? Energy. All right. Okay, so when we start a reaction, what do we have? This is easy questions to start out here. All reactants. Okay, so I'm just going to put R. And then over here, products. Same thing here. Reactants, products. Okay, so as the reaction proceeds, what is the thing that we should label that goes from here to here?
Activation energy.
Activation energy. You guys keep saying it. Eli, thank you for being here, though, because you are answering these questions and nobody else is. Okay, how about from here? This one goes from here to here. Okay, I actually tried to make the first one have a higher activation energy and the second one have a lower activation energy just to test it out, okay? This one's going to be exothermic. Is that what you're saying, Kylie?
Yeah.
Okay, we'll label Y. This one's going to be endothermic. I'm also going to see. I'm just going to put RXN, coordinate, and then energy. All right, what else can we label? You should be doing this at home too.
Enthalpy change.
The enthalpy change, yep. So from here to here. And then this would be, what sign? Negative or positive?
Negative.
Negative, okay. And then for here to here, you kind of go like that to here is positive. Now, with this one, think about it. Do we get all the activation energy back?
No.
Nope. So that's why we call it endothermic, because energy is going in. And then that one would get the energy goes in. That's the activation energy. And then we end up getting all of it back plus more. Okay. So if we were to do this, we would say like R goes to P. R goes to P. And let's go back to a little bit to thermochem. Where would you write the heat? Where would you just write there? Just write the word enthalpy or heat. So this one would be on here, right? Or if we're keeping pressure the same. Or over here it would be some positive kilojoules per mole. All right. And over here, where we put it on this one?
Right side.
Yeah, you'd say heat. Or you can include it right here. Negative kilojoules per mole. There'd be a number though, okay? I'm just worrying about the sign. Are we good? There's still one more thing I want you to label at the very, very top. Oh my gosh. Oh, yes. Let's everyone subscribe so we can get Ann to 1,000. I agree. Show that, please. This message. Congrats, Audrey. I love. What is that? There's too many things I can't. I'm just going to say thanks. I know this is ridiculous, but these people are watching. What are we labeling at the top?
Activated complex.
Yeah, I like to call it the activated complex. Now, that's I think because I'm getting old, that's like an old term. I don't know, brother, does your professor at college isn't it Iowa State, is it activated complex or they say transition state?
I said activated complex.
Yeah, I don't know if they've changed it or both are acceptable, but if you don't want to do activated complex, my voice is going. We are going to put the new term kind of is transition state. No, I can't spell. Let's ignore that. I don't think it has you could put like T for transition state. And same thing here. I'm just going to put T. Or you could do like, I don't think that that's anything in chemistry, but I'm going to put it out there. Maybe we'll make it happen. Okay, so it's TS. And I lean on here. Eli picks on me, but I'm leaning on here because I'm tired. And I don't really care. So, if this isn't entertaining, then nobody's going to watch it also. And I want people to learn chemistry and be slightly entertained.
How's it less entertaining? Debbie Downer.
I've had Eli in class for 2 full years. Okay. And he's in chem club and he's in my academic team. I don't know what's wrong with me. Should tell him like we're not really going and we just show up somewhere. And Eli's like, there was an event? I missed it. I'm kidding. Okay, keep going. Are we done? I think this is it. What do you think? Anything more to label? That's good. Okay, so picture pages, that's about all we can label. Okay, new one. Here we go. There are a lot of people commenting. I'm not even joking around here, people. Here's my very fancy stand. Oh no. Richmond, I got them all out of order after I showed you.
Sorry.
What was next, Richmond? Was it this one?
It doesn't matter.
It does matter. I have them in order on purpose. They go like in, like, you'll see. He's always got to critique me. It's exhausting. Oh, there goes the tape. Are you going to judge my tape ability too?
You're tired.
You guys can put this on a faster speed later and just skip all this. There we go. There's your next picture. So what do you want to say about that picture? Okay, so I'm actually going to keep one of these. I'm just going to fix it. I won't play music, but I will play music at the beginning because I thought that was fun. Here we go. All right, Eli, here we go. You ready to tell me all the things you know? All right, I just pushed them together. I'm gonna move this off of here. Here we go, very fancy here. What are we gonna say now? What do you guys think you know about this picture and how it's similar and how it's different?
There's a catalyst.
There's a catalyst, yay! Okay, so you have a new activation energy compared to the old one. So you'd call like this one, I don't know how to do this. I should have done a different color, but I found out the colors don't work very well. That one is called the EA with a cat. I'm not kidding you, and Eli's gonna think I'm lying, but I had one student one time that said, you said I gotta add a cat. Like, no, catalyst. Like, they really thought it was a real cat, Dane. It was really weird. I didn't know how to reply. I didn't know how to respond. So that's a catalyst. Let me write that bigger. So this one right here is the activation energy with a catalyst. How are we gonna explain that to the AP test people when we write it on our test? What does that really do? Like, what does a catalyst really do? Nice and loud, somebody. Really nicely written. Don't just say it makes it faster. We all know that. So catalyst speeds up a reaction by doing what?
It reduces the energy that's needed to be put in started.
Yeah, it reduces the energy that's needed to create products or to get it to start or to get the collisions happening. When we end this, I'm going to talk about collisions. We'll draw the Maxwell Boltzman distribution and show how this slides over. If you know what I'm talking about, that's one of the pictures coming. So it allows more collisions to happen that are going to have the activation energy. It's a pathway there. It's a lot of people on here. Oh my God. Okay, go ahead, Dan. What were you going to say? What, you say it again though, because you always say it better than me.
It does so by finding
He does.
Lowers the activation energy by finding an alternative pathway that requires less activation.
I hope you heard that because that was really good. Write that. Right?
It's not necessarily a different way of doing it, because it might make you think it's a different reaction.
Yeah, you want to say just
It's
the same. Allows an alternative pathway is what I've heard.
The catalyst is there as a product and as a reactant, but it may or may not be involved in any of the intermediate reactions.
Yep, and we're going to do that. I actually picked some really hard ones. Kylie actually helped me pick a really good one for the last question is the hardest one. So these are the easy ones, by the way. What else can we say about this picture? I don't know. I think we might be done. Does it still have transition states and it's still exothermic? I think we're good. Let's be done with this one. Is this one good? Everybody's in my class, everybody's saying, yeah, we're confident. I don't know what else we can add in. Think of something. I don't think we have anything. Well, I put up a new picture. You guys think of it. I don't think I have anything else. Oh, I know. Don't say that the reaction is more exothermic or less exothermic or more or less endothermic. It's not. It's the same amount of energy. This stays the same. Okay? The energy of the reactants and products stays the same. The bonds you break, the bonds you make, all stays the same, okay? All it does is make it faster. Do not think that it makes more energy. One year they tried to get students almost to say that, or it's more thermodynamically favorable. It's not, okay? Doesn't change delta G, doesn't change delta H, doesn't change delta S. Are we good with that? Changes no thermodynamic functions. How does that feel, Dane? That's right? That's a good one. Really drive that home because they'll try to talk you into that. Okay, here's the next one. This one's crazy. Okay, here we go. Next picture. Picture pages. Look that up later. Here we go. Very fancy. I'll try to even get this one a little closer. Yeah, you're seeing that right, okay? I'm going to draw these on the board. make sure they can see them. Here we go. My students should be thinking about what they're going to tell me about this picture, these pictures. I'm not sure if I even showed you these guys yet. Have I?
No.
Now I gotta be really careful how I draw these two because I really want them to be, how about I have them there? Oh, it turned. Because my setup's so fancy. There we go. Okay, I'm gonna look at the first one. Remind me which one's where. This one, I think I did this. Didn't I do this? I went like this.
So.
And then I went like that. And then like that. And then like that. Is that close enough?
Yep.
Okay, here we go. The other one goes like, oh boy, this. And like this.
Yeah. Endo.
Oh, and then I made it endo. Is that good? Looks really bad. Was this one?
Yes.
Close enough. Well, there's something specific. Nope, Eli, hang on. There's something I need you guys to see. I was tutoring a student. Yeah, that's good. I was tutoring a student, and this came up, and it really made a lot of us think. And I ended up finding on the internet there's a lot of disagreement with this, so this might clear it up if even some AP Chem teachers watch this. I had to go on the internet and check even. I think it's Chem Libre text. It's out of Europe, I think. Okay, here we go. So let's label what we know. These are very different. Same thing down here, though. So the reaction coordinate, energy. All right. What do we have going on here? Who's got some ideas? Oh, people are answering this time. Multi-part reaction. Yay, hard chem question. And then the rest of these, catalyst lowers activation are good. These people are answering. Good. Okay, what do you guys think? That is it is going to be a multi-step. So I'm tying this into the next thing. Is a reaction mechanism. Okay, so I'm trying to go from one to the next. Okay, I think young brother over here knows what's happening here. He knows where we're going with this. I have these in order on purpose. Richmond and I were previewing them and got them in order. Here we go. So what are we going to say for the first one? It's got an activate. It's a little weird. Don't judge my drawing. A little weird. Got an activation energy to here to there, right? We're going to call it the activation energy of the first step. Okay, or the first elementary step. So it's going to be a multi-step, elementary step in a whole reaction mechanism tying it in, okay? The next activation energy is only from like here to here. Okay, this is the easy one, by the way. This is the easy one. Then you still have this, which is going to be, I should really draw these closer here. Be careful on the AP test. Really try to make sure these arrows hit, I don't know how picky they are, but top to bottom. Still exo. Are we okay with that? And then I liked this. I saw somebody else do this. I won't say who. I'll just do another color. They showed like if this was just written like the other one. I liked this. I'm totally stealing this from another teacher I watched and heard and looked at. If you took out the multi-steps and you just drew that's like the easy one we just had. I'm pointing the right one. That one, okay? So this is what we're used to seeing when you first start reaction. They just put all the steps are hidden in here. I thought that was really creative to show that this is just somebody saying, don't worry about the fact that there's many steps. Keep it simple. Let's not scare the youngsters, from majoring in chemistry. Then they're saying, no, sorry, there's actually almost, a lot of reactions happen in multi-steps. You can all do this. I'm just praying. Okay, they're all voting. They're all helping each other out. Okay, here we go. So next we're going to do is say transition state number 1, transition state number 2. Anybody have any idea what's going to be sitting right here? Something that's created, then consumed in the reaction. Intermediate. So I'm just going to put I. So if you're not watching this, I'm not writing all the words because it's going to take too long, and we're already at 20 minutes. So that's it. That's where the intermediate sits. It's created and then it's consumed. Could you still put a catalyst in here? Sure. But we just take this whole thing down, all of it. Okay. What else? Which one is the faster step? Okay. So if you have steps here, so there's going to be elementary step 1. step 1. And then, let's just say it's A turning into B and then C, okay? Then you've got elementary step 2. And then let's say that's got C turning into, I'm trying to make it simple here. Let's just say turning into D. Let's not say there's a catalyst. So which one is the intermediate? This is a little test for the next one, the green one. C right here. So like I would be that intermediate. And then what you would do is say, really, this reaction is A turning into B and D. Now I'm just making up letters because I really don't want any of these reviews to be practice AP exams. There's all of that on the internet already. So if you really want somebody to talk you through all the past exams, that's on the internet. Go find it. Okay, those I can give you the names if you want. But I don't want that. I want this to be a very generic help because they're not going to give you the same question that was on last year or 2 years ago or 3 years ago. I've taught AP for 17, 18 years. It's never been the same question. So stop. You need to know the method, right? So brother's test he took. What year did you take that test? Last year is not the same as little brother's test. That's crazy. Like who knows what they're going to have? Last year we ended with photoelectron spectroscopy. 1 year we had, we were shocked about the chromatography. I don't know. People every year have some question that's just shocking. Was that your year too or the year before that? He was 2 years ago. Who knows? Okay, so you need to know the concept. Okay, here we go. What about which step's the fast one? And tell me why. So you would say slow or slow, fast or fast. Which one's fast? Which one's slow?
I2 or T2 fast.
Yes. Now be careful. I'm trying to make a trap. T2 or this one is the fast step, not because it has a low activation energy. So if you thought that, you're wrong. Okay, this is where it was all over the internet wrong. This transition state is at the lower energy. That is why it's the fast step. Sorry, the fast step. Okay, so this is fast, and then this is slow. Ooh, I cannot. Oh my gosh, that was embarrassing. So when you write the rate law has to do with this step. Now I didn't put a lot of things in there. I'll fix the next one. So it's just based off of the slow step, the rate law. Okay, and then the overall has to match the reaction that we're looking for. Okay, let's go to the next one. Now think about this one. Be very careful. Okay, I'll just use these same letters. They don't really make any sense. Okay, C is still going to be our intermediate. I'm just going to put it back. Still the intermediate though. Okay, change that though. Okay, this is exothermic, correct?
Yes.
Okay. Reactant, product. In this case, it's A. You could say A is the reactant, and B and D are the products, okay? Who cares what those are? All right, next thing, we got activation energy, pretty large, okay? EA, 1, transition state 1, activation energy 2, smaller, transition state 2, transition state 2 is at the higher spot. So who is the slow step now?
T2.
T2. Oh, wait, why is it the second one? People are asking. I don't know. We're just going to have to keep going. This one is the fast this time. And this one is the slow. Are we okay with that?
Well, label it as T1, T2. Just some fast.
You mean T1, T2?
Like R to C or A to C with the first activation. Is this low or fast step?
This is actually the fast step, even though the activation energy is high. So then A, then you could say like the intermediate C, we're not going to worry about what's the transition state because really we don't see the transition state. The transition state is actually like, in this case, like some kind of A, B, C all bonded together at some point. Does that make sense, Eli?
No, I get it.
You get it.
When you're like saying
Okay.
fast, slow, I can see where someone would get lost.
Get lost. Okay. Are we okay with what's the difference between the two? So in the end, let's just summarize it for everybody that might be confused. Okay. What do you think? You're looking for when everyone has the highest transition state to decide who's the slow step. Activation energy could be an easy one where this one's big, this one's small, and then it kind of matches. This is the nice, easy one. This one's harder because this activation energy almost tempts you to think that this is going to be the slow step, and it's not. And it took me a while. I'm positive of it, by the way. I'm like 100%. Because I sat one night and looked it up because there was a lot of chem teachers that said, this is the slow step because the activation energy is the highest, and they're wrong. This is the slow step because the transition state is at the highest. That's what governs it, okay? All right, are we okay with these? This is also, by the way, what else is different about this graph?
Endothermic.
Yeah, really almost like really endothermic, right? So if this reaction was spontaneous, what would make it spontaneous? It probably is not enthalpy. I'm tired. I know he's like, don't lean, I don't care. Plus I'm thirsty. What makes it spontaneous or favorable? Positive delta S. Yeah, you're going to have a very entropic system to make that. What do you think, Dane?
And the high temperature.
And possibly a higher temperature. Yes, I like both of those. Remember your delta G equals delta H minus T delta S. Parts here. Here we go. New picture. How we do? We're doing good. Here we go. These are the harder ones, though. I told my students this one and the last one are going to be the slowest one. So we're gonna move. And I would love to reply to all these wonderful people. I can't even talk. Just drinking random solution like a boss. You know, AP Chem students are funny people. I would love to just have like only AP Chem students in an entire school. We would have a blast. Not that we would blow stuff up. Not that kind of blast. We would have so much fun. It would be the coolest school in the whole world. You just go to school there because you love chemistry. I'm going to start a school like that. Josh, you with me?
Yeah.
Do you want to be a teacher? I'll hire you. We love hiring people here at our school that are previous grads. There are 4 students in this building that are now teachers. I had them as students, and now they teach here. I won't say who they are. It's embarrassing. Here we go. Try another one. This is not quite a picture. It's more of just a reaction and some questions. Okay, here we go. I'm going to write these up behind me. I don't know if my students, can you guys even see these? I guess kind of look around or I don't know. Abby, closer is better or worse? I wrote them pretty big. Are you just watching it live?
Yeah.
That's a smart move. Kylie does that. She didn't do that today, though. Then I'm just going to slide these forward for your benefit. Here we go. Just taking a break. Don't worry about it. Oh, okay. As I erase this, are you guys sure you're okay? Because that's tough. I don't think they're going to put this on there. But man, if they do, we'll be ready. It was on 1 year. It was a while ago. Students came back wigging out about that. Every year there's a question that students come back and they're just like freaking out about. Last year was the last question. I think your year it was the simple old just chromatography. People, I don't know. Okay. We're gonna have to go quickly because I kind of introduced this one. Those are little tiny K's, by the way. Little K. Rate constant K, not equilibrium K. Is it still raining? I can hear it.
Yeah.
This year is my chem teacher's first year teaching AP, so I'm lacking on some concepts, and these review sessions have really helped. Aw. I used to be really like, I'm not helping any other students. I want my students to pass. I don't care anymore. I had a dream. Big brother knows this dream. I wanted everybody to take it and everybody to pass. It's been 17 years. I've given up, okay? I'm not giving up on these people here. I'm just giving up on the dream of everybody passing. I just want a lot to pass. Got it, Josh? 80%'s kind of nice. 70's good. 100%, it's not going to happen. Oh, okay. You know, being encouraging. Not intermediate. Yeah, those are intermediates. That's a lofty goal. You're right. Whoever this is, they should have their real names. Whoever POSLA, I don't know who you are. You're right. It's a lofty goal. Let it die. Okay, here we go. Here's the question. I got to write it up there. I'm going to see if I can remember what I wrote because I totally made this up. What is it? 2A? I completely just went crazy and just made up some random letters. And then plus B.
To C plus E.
We're not going to worry about equilibrium today. And then C plus E?
Yep.
Okay. And then I said this was slow. Is that true? And then I said little tiny K1. And this was called elementary. I'm not going to write everything down. Elementary 1. Okay, not like you're going to go to elementary school here. Elementary 2. Oh boy. C?
C to D plus
Just,
B.
okay, to just D plus
B.
B. Fantastic. And it's some K2. I'm kind of being ridiculous with the K, so we know those are rate constant Ks. And then I asked you a whole bunch of things. Okay. Are you ready? Picture pages. What do you see? Here we go. Okay. Ring stand. Let's do this. Overall reaction, easy one, right? What would we say the overall reaction is?
2A
2A
to D plus E.
to D plus E. Got it? Okay, and we could do enthalpy and all that. I'm not doing that. What are we labeling? Next one, rate determining step. They'll sometimes say RDS. Don't do that. Rate determining step, but let's just do RDS. Which one's the rate determining step? This one, right? Okay. Because it's the slow step. That means it's the step that controls sort of the reaction. I always tease the cross-country runners. It's your fifth runner. Okay. Andrews, that's kind of true, right? They kind of control a little bit of what's happening. I ran cross-country. I was the third runner, so that made me feel better. I wasn't the fifth. Okay, intermediate. C, right? So this is our intermediate. I'm just going to go like this for intermediate. I'm just going to box it. Okay, next thing. I have, which one's the catalyst? Remember, I didn't want any actual chemicals. I'm going to add some chemicals into this one, but not right now. B, okay? So it's there in the beginning, and it's there in the end. So it's reformed. So the catalyst is reformed in a chemical change. It speeds it up. It takes away that energetic, gives it a different pathway, okay? So that's the circle, catalyst. All right, let's keep going. Rate law. Remember molecularity, these are elementary steps. It's kind of the weird thing in chemistry where, you know, you do these really hard rate law labs and then students think you have to go through a lab, and that's typically true because what did we say about all kinetics? It has to be studied in the lab. This is an experimental field of chemistry where you can't just theorize it. You need to go in there and you need to calculate and take data. So when students get to the end of the chapter, typically they get to elementary steps and go, well, then why can you just randomly write the rate law? Well, we just can. Let's move on, okay? We don't want to worry about it. So what are we going to do? We're going to say rate equals. Don't forget that word. Students lose points by just not writing rate equals. And then K1, okay? And if I do videos next year, I'm not doing any more. Why would I? Next year, I'll talk about how you can take rate constants and turn them into the big K. You can. I'll derive that next year. Here we go. What are we going to put? For sure, a bracket. Honestly, this is the least prepared AP. I'm kind of nervous. You know, something wrong. Okay. Somebody's looking forward to calculus, I guess. Okay, what do we got? What goes in there? Girl laughing at you. Same with AP Physics, too. Second, right? So it's A squared. Okay. We're not done yet. I made a sneaky one. Catalyst can go in the rate law. Did you guys know that? I may not have told you that till right now because we would just learn the basics. If anybody has their Kinetics full book, I would love to see it. Okay, Kylie's got it. I'm going to go get it in a second. Keep it right. Actually, just give it to Richmond and Richmond will get it to me. We can put a catalyst in here. It was one of those times where I was teaching AP Chem myself. So your first year chem teachers, they may not know that, but a catalyst does go in the rate law. So my students have, they have plenty of notes already. So they have like this. Okay, so they're not taking these notes for the first time. We start with a picker, okay? And then they have this, okay? So I'm kind of, I forget, this is a 4. I don't even think you can see all that. You back up. There we go. So they have plenty to look at. So if you don't have something wonderful like this, I guess have your teacher follow me on Twitter. Okay, here we go, Richmond, take it back. And I'm serious, okay? Twitter's really good for chem people. We're okay having B. Next one. Dane, is that okay? Or does that kind of shock you that the catalyst can go in there?
I can see it going that way.
Yeah, it does go in there though. Hopefully they don't do that either. That's kind of weird. That's unusual, okay? We probably won't have that, but it does go in there. Rate law we got. Molecularity of reaction 1. That one. What's the molecularity? What would we call it?
Terminal.
Yeah, I don't, again, molecular, right? Hopefully I spelled it right. That's the step 1. It actually means there's 3 things involved, okay? How about the molecularity of step 2? U9, yep. Now, I don't think they ask this stuff on the AP test, but I have seen them put it like in the paragraph. So some students can get all whirly-twirly when they read that, and they don't realize it just don't, it's fine, okay? Stop stressing about it. All right, now what I'm gonna do is I'm gonna show you something pretty cool with this one. I'm actually gonna show you a real reaction. All I did was switch these out for different things. Are you ready? So I'm gonna put in real chemicals here. So instead of A and B and C, this is a real reaction, and my students that are in here, a lot of them are in Chem Club. 1, 2, 3, 4, 5, 6, 7, 8. Josh, why don't you come to Chem Club? Just kidding. Okay, so we do this reaction all the time. What do? We decompose. Here's the overall reaction. What do we decompose hydrogen peroxide? So this is the first one I'm going to put a real true chemical change. What do we make it into? Elephant toothpaste. Genie in the bottle.
Oxygen, gas, and water.
Yeah. And really, Dane is focusing on the oxygen. That's the most important one. Now I'm just going to put both. And then really, this can be so hot sometimes that turns into a gas. There's 2 of these. And then where's another 2? Basic. Let's just do some really basic balancing to make our egos go higher. Washington State, California. Drinking more solution. Solution. Chemists have all the solutions. That's what it says in our Chem Club shirts. Okay. What do I say? 2 waters, right? Okay. Here we go. You're going to need me to tell you this, though. What do we add? We know. We better know. What is it that we add to our reaction? It's manganese dioxide 1 time. I don't want that one. I want the elephant toothpaste one. I don't know.
Is it zinc?
No, we could do that, but it's, we add potassium iodide. Okay. Okay, so what does it do? Okay, so here's the deal. I made molecules. Yay for molecules. I'm going to quickly go through collision theory. What do molecules need? They need 3 things.
Speed.
Orientation. Okay, correct orientation to break bonds. They need speed or kinetic energy to hit. And then they just need to literally, they have to collide. I know that's the silly one, but it's also like the most important one. So they have to collide, proper orientation, and with enough energy. How much energy? The answer is activation energy. Okay, we're going to draw some stuff here. Here's what happens. This is pretty cool. Here's my iodide. Boom, there it is. So the first step is going to come in. It's going to slam. It's going to turn it into, hang on, you'll have to see here. You'll see. Here's the products of the first elementary step right there. Okay, what are we going to call those? This is the easy one.
Water.
Water. Oh, let's see how good my students are. I said that was iodide ion. Now it's IO 1-. What is that called? This is beyond what you'll have to do on the AP test, but not for my students. I have them. I have high expectations. That's why I want them to be the top at their school. Right, big brother? Okay, what is this called? Hypoiodide, yay, hypoiodide. I'm more excited about that than anything. Hypoiodide, okay? Then, be careful. Then, you got another one. Harry Potter fans, here you go. Double bent, lightning bolt. I know, they knew I was gonna say that. Okay, so then what are these gonna do? They're gonna collide? What's the goal? I need some different bonds. There's magic happening below here, hang on. Here they are, I need these. Okay, here we go. What am I making? What do you guys think I'm making? Nobody knows. Do these people know? Hypoiodide, there we go. Who is that? Amanda T-I-Z, Tiz. Is that how it says? Tiz? Amanda Tiz knew too. We're making, oop, popped open. Oh no. That, and? Hang on. Another water, right? And? What's that gonna be? Okay, think about all that stuff. Here we go. So what did I just say? H2O plus IO minus, I'll just put one. And then makes. Okay, now tell me real names. Wouldn't this be fantastic if this was on the AP exam tomorrow? It's a good reaction. I don't know why they wouldn't use it. How many teachers do elephant toothpaste? You guys should tell me who's on here. I bet you your teacher does elephant toothpaste. It's hydrogen peroxide comes flying out of a test, like a tube. They probably do it. I'm not the only one, trust me. Soap, What's the intermediate? IO. IO minus. What's the catalyst? Now you see why I had those there. It was all planned, Richmond. It was all planned. Not dropping that wasn't planned. Okay, what about the rate? That's still the slow step, I'm just telling you. It is. I just switched it out. But then to the first order this time, little tiny change. Wasn't perfect, okay? I had to put something in there to kind of test you. Still K1. First step is now bimolecular. And again, these I don't think are super likely. Let's just cover them though. And then another one, right? How are we doing? Dana, did I make a mistake? Oh God, did I make a mistake?
I don't think those are balanced because that reaction, they can't be balanced, right? So how can we know what the you're saying H2?
Oh, I lied.
Plus the
There we go. Hang on, Dave. That might be it. I made a mistake. That's why you guys are here. And I have no idea why I write my twos differently. It's so weird. Dean, is that better?
That makes sense, yes.
Yeah, I had a mistake, human error, because I'm trying to slow down. He's telling me not to lean on the thing.
No.
It's still not balanced? No, we're still have something wrong here. Hang on. Yeah, there should be. There we go. How about now?
Oxygen's on the right, 2 hydrogens on the left, 3 oxygens on both sides.
So we got, let's just do this. Intermediate gone, right?
Yes.
Catalyst reformed.
Yep.
So we're good there.
2 hydrogen peroxides on one side, 2
Yeah, I wrote.
oxygen on the other.
We're good. Okay. Since I made a mistake, we don't have a lot of time left. I'm still gonna slow down.
But they are bimolecular with respect to both steps. So.
Yeah, we're still good with that. I made a human error. Lefol, little late, hypotide, intermediate, light ice, catalyst. Doesn't work very well with yeast. Oh yeah. Okay, here we go. Moving on. Oh, I want to show you this. This one looks like this. Do we know that in Chem Club this is exothermic? All the heat that comes off, yeah. Okay, so this is exothermic. So really we could have that this would have some delta H that's negative. Okay, I don't care what it is. Let's not worry about that. Do we have, this is a liquid typically, right, Dane? Liquid, this could even be a gas. Do we have entropy on our side with this reaction? Meaning, is entropy positive?
Yeah.
Definitely, right? Just with the fact that there's 3 moles of products. Right, Dane? We're good? Okay, and then do we have enthalpy? Why do we do this as a demo? Spontaneous at? All T. Really, all T, right? What do you mean, sure? Is delta S positive? In this case? Yeah. In this one, okay, this specific example, yes. And it's negative enthalpy.
It's a negative minus a positive at all T.
All T, meaning this is going to be spontaneous all T. I'm trying to tie some stuff in that we did on, what day were we here? No, today's Wednesday. We were here on Monday, right? Is that when we did? It's all a blur. Okay, here we go. Here's what I wanted to show you. I don't think they're going to make you draw this. Yet, but we will because they come up with some crazy stuff. Why did I draw that double hump camel, whatever you want to call it, okay? And then why is it lower? Why is the second one lower than the first one? Let's just label everything. I like this. Here we go, Kylie. Yes, this is that cat. Now, normally you would just go like this. Okay, make it super easy. But it's not that easy. Life is harder than that. Yep.
So double hump because there's two.
Yep, there's actually 2 steps when we add the catalyst. First step has a higher transition state, or transition state like TS. This one's the second, was lower. Tiny, cute little activation energy for there. But we overall had the activation energy. This is like the overall activation energy was still lower when we added the iodine. How are we doing? Good? I'm trying all the notes. This was the big one. Well, one of the big ones. We got everything. Okay, moving on. Next picture. Oh, God, take a breath. Hang on, I have to get my very fancy setup in here. This is gonna have to go fast. This is an easy one. You can't do, this was actually, I think, on the practice exam or last year's exam. Last year's exam. Part of this. Okay, I want you to tell me everything you know about this graph, or what else could we put on this graph. I even gave you a hint. Where do we want to put the activation energy of the catalyst? I know it's crooked. I don't care. I'm going to drink. The solution actually matches that. What are we going to put? I should make one of these people erase the board behind me. Big brother, maybe. Oh, he's like, no way. You got me kidding
My
me.
brother stopped hitting me.
He's not hitting you. Do it. Okay, no music today. I could really use some music though. Okay. I think they're actually answering each other's questions. Okay. Let's draw this. Okay, here we go. This is called the Maxwell-Boltzman distribution. Will you have to know the name? Absolutely not, okay? But let's give credit where credit's due. I always say do that, okay, if you can. And then last year, I think you had to draw this. If you look at the last year's practice or the exam, I think it was the real exam. Students had to draw that. Okay, let me pull it, stop. Off of here. Don't judge my art. Okay, here we go. So students actually had to draw this one last year. This one was here, and then this was here, I believe. Okay, and they had to draw the one because all they did was they said it wasn't happening like noticeably at a certain temperature. I don't know if it was 30 or what, and then they said it was happening at 120. Okay, so the first one I want you guys to label is T1, T2. Okay, these are 2 different temperatures. Students get really weirded out by the fact that the temperature that's here is lower, but it's just a distribution curve. Take calculus. Whoever said they're going to go to calculus next. There you go. What about T1 versus T2? Which one's bigger? Getting subscribers. This is fantastic. Which one's bigger? Higher temperature. T2. Okay, so I want you to write like T2 is greater temperature than T1. Are we okay with that? Dane made a face, but now I think he knows what I'm saying. Yeah. Okay. So then, which one has more collisions that are effective? T2, okay? Why? Because all of this area, under that curve are collisions that are effective. Let me put the axes. This was energy. You guys had the axes though. I'm just gonna put collisions. It's actually fractions of collisions, but let's keep going. We're gonna keep going. So what happens when you lower the temperature? What are you gonna say in the AP exam? There are?
Less effective collisions.
Yeah, less effective collisions. Why? What are they missing? They could be colliding. Okay, remember them? Okay, they could be colliding. They could even be colliding with maybe once in a while the right orientation, but what's missing probably? The velocity. The energy of the collisions is not there, okay? All right, now here's my next question. What happens when you add a catalyst? And then Dane's gonna ask another question, but let's do the catalyst first. Catalyst says? I say it's like lowering the bar. Slide over, people. I feel like I'm gonna be really sassy. I know I better not say it because I'll get in trouble. You kind of all secretly wish they would do this with how many people could pass the AP exam. Could you possibly lower the activation energy required for me to pass? They won't, okay? So go back to the first one. How many collisions are effective? Well, a heck of a lot more, right? That's an alternative pathway. And then even at the lower temperature, it still helped, right? It helps both. Dane, what was your question?
Well, I suppose there's always going to be collisions that have sufficient energy. It's just that more of them do at higher temperatures.
Yes, more of them have sufficient energy.
So
It's all
faster. It's still going to occur. It's just faster.
Yeah. But I also think they're going to hit, with a higher temperature, they're going to hit hard, like gas laws.
Yes.
Think about it, they're going to hit harder. Usually you see this with the gas law chapter. That's when usually a first-year chem teacher would introduce it, the collisions of gases with the kinetic molecular theory. Are we good? We're just good? He says, let's go. Are you good? Okay. This is cool. We get some, this is what stuff's getting harder here, people. This is a lot of pictures. Have fun drawing them all. Picture pages. Remember, look it up on the internet for a laugh. I really do believe that Bill Cosby did not enjoy being on picture pages. I'm not positive, but he didn't sound like he was excited. When I was a kid, I thought it was great, but now I watch it as an adult and go, he hated that. He really hated it. Now watch how Bill Cosby will like message me. I loved it. What are you saying? I gave my students one of these. Now they have their foldable, but I also gave them one of these little trinkets. Look at that sucker. You want that. A lot of this stuff you need memorized by tomorrow morning. Okay, here we go. Look, people, we're going to have to be fast on this one. I love all these graphs. That's good. There are a ton of people chatting on here. There are 23 people watching. Subscribe. Get me to 1,000 because then I can use, I'm pretty sure my phone is better than my laptop. Why that keeps popping. Let's just look at these and say what they are. This one. I'm not pulling this. I'm not drawing these. I'm going to go right to the next one. What's all this garbage about? This first, like these are all related, by the way, people. What's that? So all the graphs of a zero order reactant, a reactant, okay, or a overall that's zero, which is really weird. I tell my students in class, I was a cross country runner. This is me now as a runner. It doesn't matter how concentration is like how far I'm going to run. I just run the same speed. It's a 9-minute mile if you're curious. I don't want to go any faster. I have no interest. Okay, it's a good talking pace, right, Andrew? Isn't a 9-minute mile kind of that talking pace? Yeah. A little huffy puffy, but if you're in Andrew's shape, he'd be bored. Okay, what about this one? He would laugh. I don't know. What's your mile time? 4:46. That's like crazy. I'm pretty sure he would lap me on the track. What's the middle one? They're in order. Good God. First order. Okay. What's this one? Second order. Okay. This is for a reactant, or it could be for overall. Okay. But usually it's a reactant. Are we good? You know what they are. So if you see these, you need to look at the axes. I did this. This third one is kind of a unique one. I don't usually see that. I know Alex and I are both looking at the clock. We're going to go over an hour. I don't know if any, but I think these people don't care.
Are they going to throw a pseudo order on there?
Yes, the question was pseudo order. I actually took it off. I hope they don't do pseudo order. Pseudo order is where you don't want to study both reactants. You're kind of, it's not lazy, it's called science. You only want to, that sounds terrible. Don't quote that. You don't want to change too many variables. So what you do is you make one of the reactants ridiculously high concentration. Usually you guys study the kinetics of crystal violet fading. The hydroxide concentration for almost all of you was a huge concentration compared to the crystal violet molecule. And so what you'll do is you just say the concentration of that one doesn't change, and you're really only studying the one. Does that make sense? And I don't think, Alex has got a good question. I don't think that's going to be, sounds lazy, but it's just Science Schmidt 2019. Somebody quoted it. You guys are super fun. Okay, go ahead, Dave.
Well, how do you write out
do you remember, was it the K prime? Yeah, should we just write it quick? Let's just write it quick. You go like this. So you go right, let's just do it with the crystal violet. We did this. We said K prime was the crystal violet concentration. And then we didn't put the hydroxide in there. Does this look familiar to any of you guys do this lab? With the spectrophotometer, kind of fun, you pick the right, look back. This reminds me, good question. We talked about this after school. Who did I talk about this with? You, Dane. Make sure you look up what wavelength do you choose for a absorbance, the Beer's law plot. I know, I'm just going to preempt that. They don't get it. That's good because they're good students. They don't do that. So what you want to do is you want to make sure you pick the right color. So you'll have to choose the right wavelength. So don't shine purple light at a purple solution. That's the easiest answer. However, you want to shine a complementary color, but not one that would make the absorbance over 1. Okay, you guys look that up. I'm not doing that. Okay, so then next we're going to do is we're going to say that rate equals, here's what you want to do, Dave. The real K times the crystal violet, which I think wasn't it first order? I think it was. And then times the hydroxide. And we really didn't know. We did like X and Y. But in our lab, we found X was 1. And then K prime is the K, the real K, and the hydroxide concentration that was really high. Just said I wasn't going to do pseudo order, and here we went. I still think that they quoted that. That's terrible. Okay, it's not lazy. Sounds lazy, but it's just science. Okay, you change one variable at a time. So it sounds lazy, but it's the way you do science. Okay, here we go. Moving on. Next picture. Oh, let me put it up here. This is a big dog. We're almost there. Kylie gave me this one. This one's hard. Don't cry. There's no crying in chemistry. There's a shirt that actually says that. Somebody could send it to me. Okay, I would love it. So chemistry. By the way, tomorrow, I tell my students, you're going to be great. It's going to be awesome. Find your points. Get your points. 60% sounds terrible. Get it. Okay. Go find your 60%. Stay calm. Don't get mad. Don't cry. Don't get angry either. Okay. And if your school's paying for you to take the test, enjoy the morning. I don't know.
But a pop story.
I mean, we don't. We live somewhere where these students, either they pay it or mom and dad pay it, or mom or dad or grandma. Maybe grandma put it the bill.
Skip it if you don't know.
I'm going to make my own child pay. Yeah. Here we go. Actually, all 3 of them. Are we good? Do you have it written down? I'm going to have to take this because I have no idea. Kylie, you got this one. Okay, here we go. Oh, I never erased the board. Oh, man. I'm not going to redraw the table. How about that? Hopefully people wrote down the table. I'm sitting here holding it. I'll just show it to you one more time. Write down the table really fast here, people. Again, how many things are you changing? Each experiment you're changing, how many variables? One thing. I hate these. Wow, it's almost like I sit in the front row. See? Somebody said it's almost like I'm sitting in the front row. Because Eli told me, don't lean in. He goes, it's not like you're ugly. Quote that. Gonna get Eli in trouble. Are we good? We're doing this. Let's go. Richmond, let's do this. Let's go. Here we go. Determine the order. Okay, so we want to do H2. This is a weird reaction. Oh my gosh, Dean, are you even thinking like, what's the name of that? Selenous acid. Don't worry about it. They'll tell you. That is true. The AP test has gone away from nomenclature. I think it's a crying shame. I like it, okay? That's called selenous acid. Let's go. Yeah, makes happy. Here we go. What are we reacting with it? Well, we're also going to have hydrogen peroxide. Now, this is where it's sneaky. There is going to be another one, okay? This reaction actually said that it is carried out in acidic solution, and then there must be excess acid at the end. So this is almost like a redox. You can even look at the fact that we make hydrogen selenite. No, selenate. Hydrogen selenate. So there's a lot going on here. You could even do oxidation reduction. You could do the oxidation states.
Did you say it was selenous acid?
Selenous acid, yeah.
So wouldn't it be hydrogen selenite?
And then this is HSEO4 minus. So then that's hydrogen selenate.
Oh, I see. I didn't see that.
Yeah, I know it's tiny. It's tiny. Here we go. Here's the trick, though. They have hydrogen as a part of this reaction, as a reactant. So it doesn't show up here. That's what I think what made this tricky. But it is here. Okay, so we got to solve for all of these, and there's more trick to it. Okay, So what are each order and tell me why quickly, okay? So when you look at the table, what did you notice? All the same. Go down, this one doubled. And what happened to the rate? You can use that whole formula thing. I don't promote it. The rate went 4 times as fast. Okay, are you guys okay with that? So that means if the rate went 4 times as fast and it was doubled in concentration, what order is it? Second, okay? You need to put that in nice words, or you need to actually algebraically solve it. Every textbook out there in AP Chem or a college level has a way to show you the math. I coach my students just to explain it with words. Okay. Can't believe they duped us like that. That's funny. Okay, what about the next one? You got to look, where is it doubled? So here it's doubled, right? And check that these two have stayed the same. Did they? Okay, look at the rate compared to the first one, right? Well, I just did the wrong finger there. And then it's doubled, right? So the concentration doubled and the rate doubled. Be careful, look at, it's -8. Be careful with that -8 exponent. I tell my students, make that 7.4, make that 29, make that 15, and just leave that one alone. Are we okay with that? And then just ignore these then. Go like this. So if it's 7.4, 29, 15, and 3.7, and then just ignore the exponent. It's just going to confuse you. Just get rid of it. Okay, for now. What is it? It's first order, right? This is where it got tricky, right, Kylie? What about the hydrogen ions? So here if you compare them all to the first one, I think that's pretty much the theme, wasn't it, Kylie? It was always comparing to the first one. Concentration doubled. What happened to the rate? It's in half. That means it inhibits the reaction, which either you do, and it inhibits it by half, right? It's actually -1. Oh, I did some hard ones. I told you these were going to be hard at the end. Or you could go like this. But isn't that the same thing? In 1954, I looked this up. 1954, somebody published this paper about this reaction. Look it up on the internet. Well, not tonight. It was 1954. I don't remember what journal, but it was in a science journal. It was kind of hard. So you'd actually say something like, that slows the reaction down. Okay. Write the rate law. We did that. Overall reaction order. That's why I like the other way around. What's the overall order? Two. Oh, they're quiet. I gave them a hard one because I actually think this group's pretty snapping good. Snapping good. That's a new word too. What are the units of K and value of K? Now, if you're a good memorizer, or if you have one of these sheets and you want to memorize the units of K when it's overall second order, they're right there. And typically, this was in molarity, and it was in seconds. They're making life easy. They're not doing anything weird with centimeters cubed and all that. People are talking about strong acids. CSI on NBC for strong acid. That's a good one. Do you guys know why? CSI on NBC. Hydrochloric acid, sulfuric acid, we just talked about that today, didn't we, Dane? Wrong video, but I like it. That was Amanda again. Ooh, Amanda's good. Amanda was the one that said multi-step before anybody in here even did. Amanda, I think you're going to be okay, girl. You're going to be good. Keep studying, though. What about the K? Did you guys find it yet? What are you going to do? I need this. Here's life. Okay, why would you choose any reaction but the first one? Why would you do that? Let me show you why. What are all the numbers in the first one for molarities? 0.1. Let's make life easy, right? You could do units of K and the value of K without a calculator. This could be a multiple choice question tomorrow. Wouldn't that be great if it was, Kylie? I wish, right? Okay, here we go. So I'm going to put the numbers in there. Rate equals, well, we have the rate. We picked the first one. What am I doing? 7.4 times 10 to the minus 8. I'm not going to put the units yet, okay? I'm just going to do the math. We'll do that in a second. K, we don't know K, all right? And then we're going to put in 0.100 squared, 0.100 to the 1, divided by 0.100. Some of you who are really good, Amanda's probably done already. What happens? That's gone. Okay. What's 0.1 squared? Okay, so this equals 0.01, right? We're good? Which is really, you're going to see what I'm doing here. It's a huge 1. What in the world? Yeah? Why am I doing that? Who knows? When did you guys think you learned this? I think you guys were like Bayview age, right? 7th grade, 6th grade? I don't even know. Where did you learn this? That when you divide exponents, you subtract them. What's it going to be? -6. Okay, we got the value of it. Now, if you memorize the units, bam, then put them. If you didn't memorize the units, it's okay. Stay calm, remain calm. We can derive them, okay? I'm going to go up here and derive the units for K. Rates, units is molarity, seconds to the -1, okay? Equals K, but this time I'm solving for the unit, not the value. K times molarity, right? Are we okay? I don't hear anything. They're so quiet. Molarity divided by molarity. Well, hot dang, doesn't this look like algebra class? This is why there's an algebra requirement. We need you not doing a huge amount of algebra, log, natural log, okay, right? But we need you to be algebra perfect. Like this is easy stuff, right, Emma? I picked on Emma the whole time. Josh? Okay, here we go. What do we got? Okay, M squared, right? M, second -1, what are you gonna do? I know there's a lot of letters, but if you don't understand the letters, I don't know. At some point you go to bed. Because this is not gonna get better. I would say, do I wanna say midnight, call it?
Lights off.
Tonight?
Yeah, I wouldn't even stay up till midnight. I'd say 10. My students here, I'm saying 10. There's nothing you're gonna do between 10 and 12. And if you're past 12, you're just gonna lower your score, in my opinion. I mean, if you want to get up a little early and go back around like potassiums are soluble in water, nitrates are soluble in water, something simple. Okay. Hydrogen bondings, what elements only? F no. Fluorine, nitrogen, oxygen. Here we go. Moving on. You guys got the K?
Is it liters per mole second?
Yeah. So I'm going to do this, or you call it that thing. So then meter, that's kind of, I'm saying meters. The molarity's kind of gone, but there's a molarity on the bottom. So you would say K is either M to the -1, second to the -1. I'm not a huge fan of that. Where am I? I'm right here. I don't like this, but that is the right units of K. I like what Dane said, the units of K over here, we're almost done, is liters, moles, times second. I like that. That feels like home. Right? Are we done?
The answer book only accepted the
This one? Huh, okay. I'd say as an AP test takers are going to take that. I would say more students are probably going to put that as an answer anyway. Just watch time. Be careful. The only thing would be if it was in minutes. Just be careful. They can get you on that. Just don't assume it's going to be seconds. Hopefully they don't do any centimeter cubed or decimeter cubed, but they could instead of liters and milliliters. Okay, I'm just going to say goodbye to these people too. So Amanda says it's M. She's got it. It's 9 here. Oh, that's right, because they're delayed, that kind of thing. We're good. We hit 770 subscribers, folks. We're almost there. That's funny. Okay, bye. To my students, I'm going to say good luck too. And what did I say? Go to bed. Go to bed at 10. Hey, any advice, people? Anybody else want to give some advice? Eli, any advice for the crew as I say goodbye?
If you don't know it, skip it.
You don't know it, skip it. Come back.
Good, healthy breakfast.
Get a good, healthy breakfast.
If you don't know multiple choice, fill in a bubble and then move on.
You don't know and you know you're not going to know. Callie says fill a bubble and move on. Okay, next one. Alex, you got any advice?
Breathe.
Breathe. In. Oh, do a little meditation.
Stay alive.
Still. Josh?
I don't know.
Says, I don't know.
If you climb,
Know your
your body
Vesper
is strong.
shape.
Josh has got to know his Vesper shapes. Good luck, everyone. Nathan says good luck. He's on here. Go and see who that is. Emma, any advice? She's smiling. Perfect. Smile. If something gets you, like you read it and you're like, I don't know, look up and just smile. Just be like, I don't know, move on. Andrew, he said, eat a good breakfast. Richmond? YOLO. Dane?
If you can't guess the answer, don't bother doing anything. I want you to lose the point so I can get a 5.
Dane says he wants you to do work. Yeah. He's all about the statistics of it all. Abby, did we give you something? Remember, oh yeah, unit signs.
Unit label.
Number, unit label, sig figs is 1 point, but man, you might want it. As the veteran there, big brother,
Relax.
relax. You got this. Okay, sleep. It's a psychological
Go
game.
watch Bill Cosby.
Yes. Honestly, right now, picture pages, Bill Cosby, watch a couple episodes, laugh it off. There's some really funny ones. The train one. Okay, Bill Cosby, picture pages, where's my train? That one is a hoot. If you haven't laughed today, go watch that. You guys are great. Thank you. I wish everybody the best. And like I said, I want all my students to pass, but more can. Dane says no, though. He says, fill wrong bubbles in for me. We're good. Bye. End stream 2019. Are you sure? Yes.